Ever wondered about the invisible forces that power your daily life? Synchronous machines are at the heart of it. Now you might be asking, what exactly are synchronous machines? Well, they're a type of electrical machine that can operate as either a motor or a generator. Their defining characteristic is that their rotor speed is synchronized with the frequency of the stator current. This means that the rotor and stator fields rotate at the same speed, regardless of the load on the machine. Now, why is this important? Synchronous machines are used in a wide variety of applications. They're the muscle behind power generation, electric propulsion, and industrial automation. They might be hidden behind the scenes, but they're the unsung heroes that keep our modern world running smoothly. What makes them particularly special is their suitability for applications where constant speed and high efficiency are required. Imagine you're in a high-speed train rushing across the countryside, or maybe you're at home enjoying a cold drink from your refrigerator. Both of these scenarios, and countless others, rely on the constant speed operation of synchronous machines. But it's not just about speed. These machines are also known for their high efficiency, especially at high loads. This is a big deal because it means they're not just powerful, but they also use energy in a smarter way. In a world where energy efficiency is becoming increasingly important, this is a significant advantage. And let's not forget about their versatility. As we mentioned before, synchronous machines can operate as both motors and generators. This means they're not only used to create electrical power, like in power plants, but also to consume it, like in electric vehicles or industrial machinery. So without these machines, our modern world would be quite different, wouldn't it? The lights that brighten our homes, the machines that build our cars, the trains that take us from city to city. All these and more are powered by the unassuming yet powerful synchronous machines. Now let's delve into what makes these machines tick. They consist of two main parts, the rotor and the stator. The rotor, which is the rotating part of the machine, and the stator, the stationary part, work together to make the magic happen. Let's break it down. The rotor of a synchronous machine is a crucial player. It houses a field winding that's excited by a direct current. The field winding is like the heart of the machine, generating a magnetic field that whizzes around at the synchronous speed. Imagine the rotor as a top-class athlete, always keeping pace, never falling behind. It's this consistent speed, synchronized with the frequency of the stator current, that gives synchronous machines their name. Now, onto the stator. This is where the armature winding comes into play. The stator is connected to the electrical system, and the armature winding is like the brain of the operation. It's this winding that produces a rotating magnetic field when current flows through it. Think of the stator as a maestro conducting an orchestra of currents to create a symphony of magnetic fields. When the stator and rotor work together, they create a perfectly synchronized dance of magnetic fields and currents. But it's not just about the individual parts, it's about how these components interact. The field winding in the rotor and the armature winding in the stator have a special relationship. They're like dance partners, moving in perfect harmony, and it's this harmonious interaction that's at the heart of how synchronous machines operate. So, we've got the rotor with its field winding, rotating and creating a magnetic field. And we've got the stator with its armature winding, producing a rotating magnetic field when current flows through it. Together, they make a synchronous machine that can function as either a motor or a generator. Understanding the construction is key to understanding how these machines operate. And with that, we've unlocked the secret of the construction of synchronous machines. With the construction clear, we can now explore how synchronous machines operate as both generators and motors. Let's start with the generator. In this mode, the rotor of the synchronous machine is driven by a prime mover, such as a steam turbine or water turbine. This prime mover rotates the rotor at a synchronous speed, which is determined by the frequency of the electrical system. As the rotor rotates, it induces a voltage in the stator windings. It's like a dance where the rotor leads and the stator follows, creating a beautiful symphony of electrical energy. This voltage is then connected to the electrical system, where it can be used to power homes, businesses, and so much more. Now let's flip the switch and look at the motor operation. Here, the stator is connected to the electrical system, and the current flowing through the stator windings creates a rotating magnetic field. It's like a charm, attracting the rotor towards it. The rotor, enchanted by the rotating magnetic field, follows it around. This causes the rotor to rotate at the same speed as the rotating magnetic field, which is the synchronous speed. It's a captivating dance of magnetic fields, where the stator leads and the rotor follows, propelling the machine into motion. In both cases, whether as a generator or a motor, the principle of operation is based on the creation and interaction of rotating magnetic fields. The stator and rotor work together, each playing their own part in this electrical ballet. The rotor, with its field winding excited by a DC current, creates a magnetic field that rotates at the synchronous speed. The stator, with its three-phase armature winding, produces a rotating magnetic field when current flows through it. And that's the magic behind these machines. The rotor and stator work together to create and utilize magnetic fields, allowing the synchronous machine to operate as both a generator and a motor. This dance of magnetic fields forms the heart of the principle of operation of synchronous machines. Scene script. Synchronous machines are not just important, they have distinct advantages that make them a preferred choice in many applications. Firstly, the constant speed operation of synchronous machines is a major advantage. Regardless of the load on the machine, the rotor speed is synchronized with the frequency of the stator current. What does this mean for you? It means that the speed of these machines remains constant, no matter how hard they're working. This is a critical feature for applications where stability and consistency are key, such as in power generation or industrial automation. Next, let's talk about efficiency. Synchronous machines are incredibly efficient, particularly when operating at high loads. Unlike asynchronous machines, they don't suffer from the same losses. The result? More power output for the same amount of input, saving energy and reducing operational costs. Now that's what I call working smart. But that's not all. Synchronous machines also have the ability to operate at both leading and lagging power factors. This might sound like a mouthful, but it's actually quite simple. It means that they can either absorb or supply reactive power to the electrical system, depending on what's needed. This flexibility is highly valuable in keeping our electrical systems balanced and stable. Lastly, synchronous machines provide reactive power support to the electrical system. Now, you may be wondering, what exactly is reactive power support? Well, it's all about maintaining voltage stability and reducing losses in the system. By providing this support, synchronous machines help ensure that our electrical infrastructure runs smoothly and efficiently. So, to sum up, the constant speed operation, high efficiency, ability to operate at both leading and lagging power factors, and provision of reactive power support are key advantages of synchronous machines. These features not only make them a superior choice in a variety of applications, but also contribute to the overall stability and efficiency of our electrical systems. These advantages make synchronous machines a cornerstone of our electrical infrastructure. Like all technologies, synchronous machines have their challenges. Let's delve into some of the disadvantages that come with these powerful machines. Firstly, the complexity and cost. Synchronous machines are not the simplest of devices. Their construction involves a fair bit of intricacy and precision, which in turn translates into higher manufacturing costs. The rotor and stator, the field and armature windings, all these components require meticulous assembly. This complexity extends to their operation and maintenance too. Specialized knowledge is needed to operate and troubleshoot these machines, potentially leading to increased costs for training and manpower. Secondly, the need for excitation. Synchronous machines require a direct current or DC source to excite the field winding. Simply put, this excitation is what creates the magnetic field that allows the machine to operate. But this need for a separate DC source can introduce additional costs and complexities. It's an extra component that needs to be installed, maintained, and powered. Lastly, we have stability issues. Synchronous machines can be susceptible to problems like hunting and loss of synchronism. Hunting is a phenomenon where the machine oscillates around its operating point, which can lead to erratic performance. Loss of synchronism, on the other hand, involves the rotor falling out of sync with the rotating magnetic field. This can cause significant operational issues and even lead to damage if not quickly rectified. Despite these challenges, the benefits and importance of synchronous machines in our daily lives are undeniable. Their ability to maintain a constant speed regardless of load, their high efficiency, their versatility as both motors and generators. These advantages far outweigh the disadvantages. The world as we know it would be vastly different without them. Power generation, industrial automation, electric propulsion. All these fields rely heavily on synchronous machines. So while they may not be perfect, and while they do present certain challenges, synchronous machines are incredibly valuable. They truly are the silent heroes of our modern world.